With this, I've been teaching this this topic for sustainability for a while, and it's kind of interesting to see how LCCAs have progressed in the last years. The presentation used to feel kind of like a speed bump, something that we were trying to keep people awake for. There was a small group that actually was impacted by it, and so a lot of people kind of spaced out on us. And so in the last couple of years, it's taken kind of a center stage all the way up to the point where there was a sim note, and it got some pretty high level oversight. So with that, I just wanted to kind of put in here some items that we're not going to really go into because of time and other things. And so the items that we're not going to really dive into here are why the policy exists, programmatic studies, why the study is being done at the project level rather than the programmatic level. We're not going to get into detailed technical features or solutions. Recommend reaching out to ERDIC or industry if you're looking for things that you need to detail study. We're going to focus mainly on compliance with the policy, and then where we can, we're going to try to leave opinions out about the policy. There's a lot of opinions about it, about why we're doing it, should we be doing it, things like that. The overall goal of the presentation today is we're going to focus on compliance rather than complaints. And so with that, I'll say, questions are encouraged in the chat. I do have a lot of content to cover, and you all see that as we kind of start talking, especially the policy. Yeah, I know, Billy. And so, so do put them in the chat. We'll try to follow up with them. I will say my sphere of influence as far as impacting change on this is very small. So the answer may come back is policy, and it will probably end there, or I will say it will definitely end there with me. And I can pass it up to others, but we got to work within our sphere of influence here. Okay, so all that being said, what is an LCCA? You go and you ask your technical team, and they're gonna make it sound like the problem out of Good Will Hunting, and that's kind of what I'm trying to go here with this big blackboard is, oh, it's this thing, and you got all these things that go into this, and so you go and ask them, and you may get an explanation like that. If you go and you ask someone for an example of an LCCA, you might think you're asking for a hair from a mythical creature. That's our Bigfoot there. People have seen one. They're not sure if it was good. They don't know if it was bad. They've seen one, but you ask them to send you one, and you may not get a response. So just a little bit of a joke there with y'all, but sometimes people do kind of treat LCCAs like they're a mythical creature. I've seen LCCAs that are good. I've seen LCCAs that are bad. I've seen LCCAs that are 100+ pages with all the appendices. I've seen a lot of one-page LCCAs from AEs. When I come in, I say, hey, I don't see the tracks of Bigfoot in your project, and then all of a sudden the small Bigfoot appears. That is a one-page that says, hey, I've done a good job. Obviously, probably not the intent, but we'll get through the criteria and y'all can see that. So jokingly, just kind of, you can think of your LCCA as the mythical Bigfoot, and hopefully you can capture one and it will be existent in your project. Okay, so serious, what is an LCCA? Let's start answering some questions here. So it's the total cost of owning, operating, maintaining a building over its useful life. And so this definition is coming out of the CFR Title 10 from 436. So boiled down, it's LCCA is an analysis trying to capture the overall total cost of the facility. And this includes the first cost of construction, the cost to maintain, cost to operate the facility. That includes the utilities, the salvage value of materials at the end of their useful life. So as you can imagine, it's a really difficult thing to try to estimate all the factors that go into estimating the total cost of owning a building. It's like asking how much it costs to own a car over its life. There's a lot of factors, and specifically, one of the biggest thing is going to be who's driving the car. How are your users using it? Is it anywhere close to being used as how it was modeled? There's a lot of things that go into that. we won't go real far down that road, but how the occupants are there will impact, you know, the energy usage. It'll impact equipment life. It'll impact a lot of different things that go into making this complete circle for the balance of the building. And then you also have other factors that are less able to control, you know, the weather, other things like that. So it's ultimately holistically trying to be a study that you use to support the decision making, and you'll see some of that as we go forward here. So hopefully that gave you an idea, at least high level, of what an LCCA is. We jumping into it, we'll get into some real world examples. Maybe you can actually get a picture of what the documents can kind of look like. But before we go into that role, we'll jump into policy. And so hopefully people have seen some of the references here on this, especially if you're involved in the design and creation of LCCA. So the first one at the top here, kind of working down, is the law. You know, where we get this, and then you have the UFC. You know, that's obviously the emphasis of our webinar and compliance. I went ahead and put the ASA policy next to it. I get different answers from people on which one stacks on top of which one. The STD policy does overwrite parts of the UFC, and so I used to stack it below it, but now I'm just going to put it next to it. We're going to treat it all equally here. And then you'll work your way down into more of the USACE directed items, the engineering regulation, which is actually currently working probably towards a revision, but we'll stay on the current, what's currently exists. And then you have an ECB, which is, you know, usually how we provide stopgaps to correct issues within USACE. And then finally, you have a picture of the SIMA note that was actually issued in 2019. And to my knowledge, that got kind of rolled into the ECB 2020-8, but just kind of a high level flow of where all this policy is. And we're going to try to touch the highlights of some of these. We're not going to get real deep into all of them. The presentation would get really long and extra dry if we went that way. So we'll keep it high. We'll keep it moving along on the policy, and we'll pick these up. So the first area that we're going to jump into here as we start our journey into the forest of policy here is the sustainability UFC. So a lot of y'all should be familiar with this. We've been doing the webinar series on this, and so hopefully this reference isn't new to anyone. Okay, so what does the UFC say about LCCAs? There is an LCCA section here. I recommend, before we jump into that, is I always like to check the applicability when we pull up a UFC or when we pull up criteria. If you go into the UFC, that would be in section 1-4, and specifically there's a table 1-1, and it talks about where you apply and what applies, and the different forms. And so if you went to chapter 1, which is where this LCCA is located, it's going to say all design and construction activity. There's, I'm assuming, going to a period kind of there. It's actually a second line. It says assessment of existing buildings greater than 10,000 gross square feet. And then what we'll get into is there's actually an appendix A with this document, which covers LCCAs, and that one says all buildings that meet a statutory threshold. And then there's actually a footer on the table, and it talks about this $250,000 amount. I'm not going to go real deep into that because that could go pretty deep. I'll just say kind of that information is there, and I recommend, you know, when you kick off a project, I always recommend checking, you know, what UFCs apply and go into your applicability. And so specifically going into these tables and checking that for your projects. Okay, so now then jumping further into what is actually on this slide is you'll see some highlights there where we're going to compare the life cycle cost effectiveness of the building energy and water systems to work together to determine the resulting savings. And so What we see here is we have the summary. We're providing LCCAs for our energy and water systems, and then specifically it goes in and says LCCAs are required for the following: systems contributing to the energy footprint, renewable energy generating systems, when using life cycle cost effectiveness as a reason for documenting compliance with the UFC. And then it's optional to use LCCAs to evaluate multiple options to support the project team decisions. There's required LCCAs, and then there's the recommendation of you can use LCCAs as an additional tool for making determinations and supporting your documentation. And so then you can get into section 1-6.1, where we talk about the LCCA format. What you'll see is we have to use, or we're required to use, Building Lifecycle Costing, or BLCC program. And we're using ASHRAE 90.1 baseline for our baseline benchmark. The years are going to vary, and so you'll need to get into the UFC to actually look at the nuances of what year and version of 90.1 are you using. And we're working towards achieving a 30% energy savings. And so then there's a whole building, there's the whole building analysis in section 1-6.2. We're going to talk a little bit more about that when we talk the ECB 2020-8, but more or less noting that there is a requirement for the whole building analysis. We're going to use a 40-year study period when we do that. And then there's individual component or system level LCCAs, and these are for determining alternatives, that are acceptable, and using it as a decision-making tool between different alternatives. With that, some highlights are the acceptable alternatives must not degrade the overall building performance. Alternatives must be sound technical alternatives that are user comfort compatible, reliable, locally serviceable, user-friendly, ensure safety, and at a minimum are neutral with regard to occupant productivity and design aesthetics. So you can do a lot of things to save energy. You can turn off your air conditioning. The goal is not to only save energy, it's to be able to meet the mission while doing it. And that can go into a real long side discussion of how you determine those balances, but we won't necessarily go there. We'll just note that there's a balance here between the savings that we're going to achieve as well as being able to functionally meet the mission. Okay, so some highlights from, some highlights from the UFC Appendix A, where it specifically talks about LCCAs. And so I'll give a little disclaimer. These are my highlights that I picked out when I read the policy. This is not an all-encompassing summary, and my recommendation is if you are wondering about it, then the best thing to do is for you to read the policy and to pull out your own highlights. But for the purposes of this presentation, put some highlights up here. The items in parentheses are the section reference in case you want to go back and pull some of those. So just high level on the appendix with this UFC is we're going to do the LCCA process integration. We're going to perform our LCCAs during the parametric design process at 35% or earlier. We're also going to identify alternatives. We're going to provide 3 alternatives. And then specifically in here, it says the Army is going to select the highest energy efficiency while remaining life cycle cost effective. Going into chosen alternative justification, if you fail to meet the 30% energy savings, you're going to document that in your DA. Good kind of just general practice. So you'll see a lot of notes in this is documenting in your DA. Really, the point of a lot of this is documenting the design decision. So the best location for that is in the design analysis. So that way it can be seen and understood by individuals while they're reviewing your project, as well as for future knowledge. So balancing energy and operations and maintenance. So balancing the increase in energy efficiency against O&M cost and initial cost. really trying to find that balance between a really high efficiency system and as well as something that has maybe possibly a lower O&M cost or lower initial cost. So finding a balance between those. Building envelope, you're going to, if you're using an existing building, you're going to assume that same assembly with a current ASHRAE 90.1 compliant U factor. You're going to give preferences to durable features, and when you have LED lighting, you are not required to provide an LCCA. So those are some high levels with that. We'll keep rolling through here. Specifically, installation preference doesn't supersede service policies or this UFC without an approved exemption. Not going to go real deep into that, but because I don't want that isn't enough of a reason. There's a process with that. Funding of the system. So if items are in the DD 1391, they're required to be provided, and an LCCA is not required. I'll say this statement assumes that the LCCA was performed when you were adding the items to the DD 1391. If not providing an LCCA, then recommend a statement in the DA as to why. So, if for some reason you're not doing that, it's always a good idea to put those statements as to why in your DA. More or less, think about the DA as your breadcrumb through the forest of, can you go back later and retrace why you made those decisions? Energy modeling. So complete the LCCAs no later than the parametric design. So then they list in here 5 to 35%. If you have significant changes in your project scope beyond the initial design, you're required to update your LCCA and your energy model. LCCA documentation is in the design analysis, and it should be available for third-party review. And then design build projects. LCCAs are prepared during the development of the solicitation package or by the RFP preparer. The systems and features that are incorporated as requirements into the design build RFP. The criteria, the selection criteria isn't going to deviate. And if an offerer, if a contractor provides an alternative, it's supposed to increase the energy efficiency rather than decrease. And if decreases in energy efficiency would not be acceptable. There's a lot of content in that appendix. I encourage y'all to go in there and read that. There's some things with that. Okay. So next we're going to jump into the ER. So we're going to go a little bit further down our policy forest here. Excuse me. And so y'all might wonder, why are we skipping the ASA STD policy? It actually doesn't state a whole lot of guidance on the LCCAs in the policy. It has requirements for when you consider systems and features to implement them if lifecycle cost effective, but it doesn't give as much direction as the UFCs, the ERs, and the ECB. So definitely still review the STD policy, but where we are with this presentation, trying to work towards some of the compliance, it was a little bit, the time was a little bit better spent focusing on the UFC, the ER, and the ECB. So now we'll jump into the ER. Okay, so once again, recommend starting with what applies. So with the ER, we see the projects within USACE, or where USACE is the design agent, and it's vertical construction for projects greater than 5,000 square feet with a cost over $3 million. So I'll say this, this ER is circa 2017, I believe. And I believe there will be changes coming that will get it further in line with where the UFC is with the 10,000 square feet. We'll stay current with what the policy shows right now, but I do believe that they are going to work in that direction. And so just an interesting note with this ER is if you're below the threshold, you're not required to comply with the ER. So something interesting there. Energy modeling. So I'll kind of bring this up. There's some requirements. So this ER is actually energy modeling and life cycle cost analysis. They lumped them together because they're like peanut butter and jelly. They work together well. They go together quite often. So just wanted to point out a couple things, not go real far down the energy modeling rabbit trail. We'll pick more of that up when we do the energy presentation. But your energy model requires a full year simulation, the 8760-hour simulation. That's kind of your yardstick for your energy model. So sometimes you'll see AEs and others try to do something less. But your energy model is supposed to be held with that yardstick. And then there's actually a note in here that energy models are not to be used as a predictor of the energy consumption after occupancy. I like to think about the energy model as kind of like a miles per gallon sticker for your car, which eventually I guess that's going to go away. But anyway, miles per gallon sticker for your car of, you have this thing, but the weather, the driver, all kinds of factors, your maintenance, all kinds of things can impact. And so it's more of a assumption. And really what we're using this energy model for is to document an analysis to compare two alternatives. And so we're somewhat working in a vacuum. We're trying to model as many of the real world parameters as we can, obviously within the limitations that exist. So then we get into section 7 where we actually start talking the LCCAs. And so then there's some interesting things. An LCCA is required even if you're meeting it, even if you're meeting the energy metric, even if you're exceeding the energy metric. So if you're doing 35% savings rather than just the 30, you're not excluded from it. And then even if you don't hit the metric, you provide an LCCA either way. So just kind of boil that down is just know you're required to give an LCCA. We're going to do 3 alternatives when we analyze this, and then the ER allows for logic and experience. This statement can be your friend. If and I put in the slide some of the statements from the ER. Good engineering judgments allowed, where it's clear that the cost of an alternative exceed the savings. Do not perform the analysis. Rather, use judgment and experience to select cost-effective features. I'll say, there's 2 sides to this coin. There's the side where you can sign off everything, but you're required to provide the documentation. So that statement is in there. I would use judgment when applying it. And then you're going to document this in your design analysis. Hopefully y'all are getting familiar with hearing that statement of documenting it with your design analysis. I'll say if you use engineering judgment, I would definitely document that in your design analysis. That way it doesn't look like you just didn't do it. And then similar performance. So this is where the Army ER has kind of an interesting statement. So if you have similar performance between the alternatives, it says to select the most economical. We'll kind of point out later on, there's some other parts of the criteria that point out to choose the higher energy efficiency. So this might be an area that may change to fall in line with some of the other criteria later, but currently it says to choose the most economical if alternative A and B are similar. And then finally, centers of standardization. Standard designs that have an LCCA do not require another LCCA. And I'll say major changes to the standard require an LCCA. So if you can keep from messing with the standard, which is sometimes a hard thing to do, you do not have to do an LCCA if one exists. So that's a benefit there. Okay, so that was a real high level of the ER. And so the goal of this is to try to capture some highlights. It's not necessarily a deep dive. And so now we're going to jump into the ECB. I'm seeing some of the questions. I think we're doing pretty good on time. We'll try to pick those up at the end. So sorry, my screen setup is real kind of weird. I'm probably mess up my screens if I try to actually jump to the questions right now. So I apologize for that, but we'll pick up what we have time for when we get to the questions part, and then if nothing else, we'll pull the chat down and we can try to get some of those answers distributed. So appreciate the questions. Not trying to ignore y'all. It's just I don't want to mess up all my screens for that. So we're going to jump into the ECB. So this one is by far the newest. This is where we'll actually park our journey through the criteria forest. So we'll start with there's a sim note, and it actually talks about, Headquarters Army audited USACE projects and found a lack of compliance in regards to the SDD policy. So it was a note directing action, and it was directing action for us to get in line with the policy and to perform the calculations. So okay, so jumping into the next one is applicability. So you're getting probably kind of used to hearing me say, check to see what applies. I'll say with this one, it's a lot like the UFC and the ER. There's no unexpected changes by this ECB. And then we'll jump into steps to the LCCA. So this ECB is really good for if you're looking for how to actually get into doing your LCCA. And I'll say there's an attachment A. We'll kind of summarize that on the next slide. But it goes pretty good depth into trying to give you the knowledge to how you would actually walk through some of the processes to creating specifically the whole building LCCA, which is one of the items that was kind of flagged from those audits of non-compliance. So with this, with this ECB, we're still going to perform our LCCA. It says actually during code 2 and 35% design process. We're going to give 3 alternatives. And when we select the alternatives, we're going to give preference to features and systems with lower complexity and maintenance burden. So this is something that's a little bit different than some of the others, but it is trying to find that sweet spot between efficiency and reliability. And then another big thing from this ECB is quality assurance. So it adds a section in here on quality assurance, and this is where it talks about your district subject matter experts are going to review and approve the alternatives that are proposed for the analysis, and that they're going to include a signed statement that the LCCAs have been reviewed. And it goes on to give responsibility for the LCCA to the technical lead for ensuring that the LCCA is performed and documented in the DA. So obviously trying to work towards compliance, and so putting in a quality assurance that makes sense with our USACE processes of we have QC and QA here, but we see from this ECB of some roles being assigned or some tasks being assigned with this. And then the ECB also talks about design builds. I'll say those statements mimic pretty close to the UFC. There's a little bit more depth in there, so it's definitely good if you're going down that road with RFP development or something like that. Yeah, and so I did actually see that question pop up. Yeah, and it talks to which disciplines actually in the ECB. It primarily says your architect, your mechanical, electrical. I think they even lump structural in there. But yeah, in the ECB, it actually spells out who your SMEs are that are to be signing off on this. So now we'll jump into this. This is a real high-level picture of the attachment A chart that I was referencing. And so this actually talks about kind of the process for creating this whole building lifecycle cost analysis. And it might actually roll up more than just the whole building lifecycle cost, but forgive all my little note bubbles on there. Those are just, I make a lot of notes when I read the policy. You never know when you're going to be asked to give a presentation on it. So anyway, this is a table here. Real high level is it's going to have you looking at your passive systems first, and then your active systems. So like your HVAC system, your electrical, and then finally your renewables. And so it's working a little bit in that kind of let's pick the biggest benefit items. If we can do it passively, then let's do that, and a good conservation of funds kind of attitude. And so you'll see is you're really kind of doing kind of an analysis of the building envelope, and then you're going to do analysis of the HVAC and domestic hot water, and then finally kind of roll into your renewable energy system. And so this can kind of look a lot of different ways, and there's some direction in there, but overall the goal is to get a holistic analysis out of the end result. Is to not just look at one individual piece and kind of work in a vacuum with relation to some of the others. So I just rattled off a bunch of policy at you, and I understand that. And so one of the first things I kind of like to do is actually let's give a crosswalk. We got a slide up there, and we had at least 3, maybe 4 different policies. So where do these things cross together? Hopefully this is a beneficial item for y'all in this presentation. We're going to document in the design analysis, probably the 15th time I've said that, but we're going to provide a comprehensive summary. So we're going to provide documentation to the level of detail that a third-party reviewer or audit team could duplicate your results. More or less, we're going to explain why we're making the decisions we're making through the LCCA process. That's probably one of the easiest things to do is stop, take the time, actually write down why you're making that decision, and it'll benefit you later, especially if you were to go into an audit type scenario. Kind of think about keeping your receipts if you were going to get audited by the IRS or something. Of having that paper trail will be very beneficial to you. So then we're going to see the whole building lifecycle cost analysis is required. Hopefully people have picked that up. We're going to provide one that has 3 alternatives. We're going to do a 40-year study on that. And so really kind of want to emphasize that may be a new process for some. Hopefully with how long some of this policy has been sitting out there, this is not fully new, and people have worked to tailor their processes to incorporate this if they weren't previously. Our energy and water consuming systems, we're going to provide an LCCA, and I'll actually cover a little bit more of this on the next slide. We're using ASHRAE 90.1 as our baseline benchmark. Hopefully people are familiar with that. If you've worked in the lead realm at all, you're pretty used to this is my starting point, and then I'm going to grow. In theory, you should be pretty familiar with that even through the UFC. So we're going to use the BLCC tool, so you can get onto the app portal and you can get BLCC. It's not a crazy difficult tool. If you get some familiarity with it, it's actually pretty simple. And so then we're going to perform our LCCAs at the parametric design, so 5 to 35% design level. The thought process that goes into this is it doesn't do us a whole lot of good to do an analysis at the end of the project and then not have time to actually incorporate it. So when we're making the design decisions is when we want to do our cost analysis. If the cost analysis whole purpose is to help us make design decisions, then we should do it at that point. Energy efficiencies to be balanced with operations and maintenance. So that's pretty. We're used to hearing that now of we're not only going for energy efficiency, we are going to actually try to balance this thing with our operations and maintenance, and that's a whole conversation that can go a lot of different ways, but just know that is there. If we have our DD 1391, if we have items on that, then we're not required to do an LCCA. So if solar PV or something was in your DD 1391, we're not doing an LCCA to necessarily option that out. Then design build LCCAs are performed during the RFP development. So that may be somewhat of a new process for a lot of people, but we're making those decisions and we're writing our request for proposal around the decisions that were made. So that way we're not putting that that analysis on the contractor and then dealing with that they may not have bid some of these items into their project. Okay, so here's hopefully something semi-helpful here. This is a little bit of a policy crosswalk. This is circa February 2020, but this is going in and trying to figure out what life cycle cost analysis are required. It was kind of like the Bigfoot of you need LCCAs, and then well, what LCCAs are required? How big was Bigfoot? Was he throwing rocks? Things like that. So this is me trying to put together a list from the different criteria of what you might expect for LCCAs on your projects. I'll say this is not holistic. This is not written in stone specifically because some of these things are not going to apply to your projects. I'll say you should have a whole building LCCA. You will have energy consuming systems, on-site renewables. That one can maybe ebb and flow depending on how many studies have been performed in your area and what the economics kind of looks like for that. I'll say we get to our first kind of optional one, individual component or system LCCA. So this might be, if you're looking and you're wanting to use an LCCA for a justification of, heat recovery on a chiller or something like that of a one-off thing that is a solution that you think might be valid. We are trying to work to provide sustainable solutions. So where we can, if we're providing things that we think are good solutions, we can do life cycle cost analysis to support our conclusions. Alternative water. So if y'all tuned in last week, we talked about alternative water. Obviously, if you don't have alternative water, then that may not apply, but we do actually have requirements for condensate harvesting and some of those kind of things. So looking at some of that, I'll say with water, that's usually a pretty low cost utility. And so trying to justify doing extra things based on cost might get kind of difficult. Solar domestic hot water. So this one's been around for quite a while. People are pretty used to seeing this. I'll say, 30% is our metric, but when talking with ASA and some of the others, they're interested in seeing if there's a break-even point. If 30% isn't cost-effective, but 60% would have been, did we look at it in that level? And so, obviously, there's good and bad with some of that. But the overall goal is solar domestic hot water cost effective? And then in here there's irrigation meters, and then there's LEDs, and so this is actually where the policy kind of differs on the LEDs from I believe the ER, where it said if you're using LEDs then you don't have to do the LCCA. So you would kind of need to balance that, but just wanted to try to give people at least a look at what might be some of the LCCAs that you would be looking at from the criteria for implementing in your project. Okay, so we're going to real briefly talk tools of the trade, and I'm already at 45 minutes here, so that's kind of where I was worried I was going to be. Is there's a mountain of policy here with this, so not going to get real deep in tools of the trade, but just kind of wanted to highlight it for y'all. If you've been working in this realm, then you've probably seen a lot of some of this stuff. It won't be drastically different. So if you're doing a whole building life cycle cost analysis, you're likely using your energy model. And so typically, your tool of the trade is going to be your energy model. We kind of talked about the yardstick of the full year energy model. A lot of times I'll say this falls on your mechanical engineer because they're already doing probably, if it's like our group, you're using Trace 700 or going to 3D Plus or system like that, of some kind of whole building model, and you're using that for your lead as well as your UFC reporting. So you kind of have that tool, and so it's really kind of taking that and running alternatives with that energy model. We saw in the criteria that BLCC is required. That's probably a pretty old That's probably a pretty old picture because I just stole it from another one. The version years change, so go onto the app portal and get the latest one is what I would say. And then cost data. So cost data can be a real difficult thing to get. Our picture here is the RS means catalogs. I think I saw something pop up from some people that this is what they use for their costing. It's one of the resources that we use in our in-house. Is we actually go out and buy the books, and I'll show you later is we end up making a spreadsheet, to capture these costs. But there are some other things out there. I'll say I don't usually go to an equipment rep and ask money things from them, because usually I'm just trying to get all the support I can from them that I don't, with selections rather than bugging them with prices. But there are some tools. If you are really good friends with your cost estimators, they may help you. I've probably used up a few friendships from my cost estimators. I think they screen my calls now. So good luck with that. But yes, there's tools out there for the cost data. It varies wildly sometimes, depending on your selections and how things go. And people that are familiar with government estimates are probably kind of seeing how differently sometimes the estimate can look from the reality. And then maintenance data. So maintenance and salvage value data, those can be really difficult to estimate as well. Is how much is this 30-year-old chiller worth, when I try to go scrap it, things like that. There's maybe some data out there. I'll say some of that, how much O&M, cost should I assume? Some of these are pretty hard variables to actually kind of punch in. And then equipment life. This one's maybe a little bit easier than those other two, because ASHRAE actually has a table out there that's, here's what you can expect for your equipment life. Obviously, the real world can vary wildly depending on the climate, the location, and other things like that. So like I said, real high level overview of the tools that may be seen when you're doing LCCAs. So now I want to kind of jump into some real world examples. I promised to show you all Bigfoot here, so we'll get closer and closer to exposing the truth. So just start out with, what would an LCCA look like? And so here's some requirements for the documentation. It's a narrative, so some kind of write-up explaining, what was going on, what was studied, your assumptions. If you can, a schematic of the systems is always a good idea. The picture's sometimes worth 1,000 words. Supporting calculations, if we're going to have a third-party audit team actually be able to duplicate the results, then they're probably going to need to see some calcs that go with it. Cost data, what did you actually plug in as your inputs for your cost, and then assumptions. And assumptions can be, things like, here's what I assume for my salvage value. Here's what I assume for my operations and maintenance, writing down these assumptions. And so I'll say, if you're wanting a kind of ballpark is, an LCCA will range, from 10 pages. And then, like I said before, you'll see some of this stuff that, you'll see some of these where you have an appendix that's 50 to 100 pages, depending on how many reports they pulled out of their energy model. I've seen some big ones, and I think sometimes they just throw all that in the kitchen sink in there, so that way they assume you won't look at everything. Okay, so jumping into a whole building LCCA. So real high level here, we're going to find some Bigfoot tracks here. This is an LCCA for design build RFP. The intent is not to make this, the district or the USACE template or by any means, but it was just simply to actually show people a real world scenario, what some of the stuff can look like. And so the next couple pages are actually the summary from this LCCA. We can kind of highlight from here that you're actually going to see that they state a purpose. They talk about how they're going to study the envelope, the HVAC system, and then as well as solar thermal. So they try to roll everything kind of into one study. we see listing the different alternatives. We see the listing the assumptions. We see listing a summary of results. That's always kind of nice, is what actually happened out of this. And they actually talk about sensitivity analysis and some other things in here. And then, so this first part talks about the HVAC. The second part, kind of towards the bottom, starts talking about the envelope. And then we get into the solar thermal. So really, it's kind of a long write-up, but kind of covering the different points of assumptions, of results, and things like that with the and then on the last page, you actually see an appendix that talks about the table of contents. So, this is where we actually pick up the support calcs. This is where we pick up our cost data and things. We can see that actually with this one, they used rent screen as a support for the solar thermal. So any kind of outputs from your energy model or your other tools that you're using to help support your overall. I didn't go in and pull all the appendices for this. I just kind of wanted to high level, if you go look at the ECB attachment A, you'll kind of see those pieces and parts of, the passive, the active, and then the renewable systems captured there. Is this one the perfect example? Maybe not, but, we took our blurry picture of Bigfoot in the woods and we tried to use that as documentation that it exists. So I'll jump into another kind of real world example here. This is an HVAC systems LCCA. So this is one I actually did. And same kind of thing here is you see the narrative, we talk about the purpose. This one I actually had a bunch of time and they let me analyze 8 different alternatives. And so we were looking at a bunch of different HVAC systems. I state my assumptions and then I summarize my results. So that way, if you went and you looked at this, you could reasonably conclude what was going on in my brain when we were doing this analysis. With this, I went ahead and made some schematics. We were studying a bunch of different HVAC systems, and so trying to kind of state where we were drawing the lines. What level of content were we evaluating this? I'll kind of point out, these analyses are being done at 35%. So you'll have to kind of bear with your LCCA preparer of the design may be less than 35%. You think about that parametrically, with cost estimating, usually that's a cost per square foot. So you got to kind of, usually your mechanical systems, some of that stuff are fleshed out a little bit further, but you're still at a 5 to 35% concept of design. So not expecting to see 100% design level in your documents, in your schematics, things like that. We're not showing all the valves and things to that degree. We're really trying to just pick up the major pieces and systems. So then jumping into, we use BLCC and so providing the BLCC outputs. So these are the summary of results. And so you can see on the left, that's the summary of results that ranked from lowest cost effective to highest. And then you can actually see the second one is a sensitivity study where we messed with the utility rates to see if our analysis was sensitive to rate change. If I jack my rates up by 30%, am I going to get a different winner? And so this, the intent of this slide is not to tell people choose one system over the other. This was done in 2015, and it was subject to that specific one. But just overall, just showing it provide your summary so that way people can see the output result from BLCC. And then support calculations. So actually used an energy model to create this, obviously, if we're modeling different HVAC systems. And then also had some hand calcs, which were really more just documentation of assumptions. What was my domestic hot water demand? What was I assuming for reheat, things like that. And once again, they were real high level of, here's an assumed, cooling per square foot kind of level, because I actually hadn't finished all my HVAC loads and everything. And then finally, a cost table. So this is a Excel sheet that we use more or less just to pick up the sum of the equipment is kind of one of the things, is here is we break down the equipment and we try to pick it up, but we try to keep it at that macro level of, what are the big pieces that we need to somewhat account for, but knowing that we're only at, less than 35% design. So it, like I said before, a 35% cost estimate is going to be, more or less cost per square foot, somewhat assuming that level of content on these. It can be a little bit difficult if you've used RS means, it's real kind of hard to get a system kind of cost per square foot. Sometimes you end up having to go in and take the bigger pieces and kind of make assumptions on, here's my cost per square foot or something of this system. Just a couple things I'll point out is it's a good idea to cite your source with this. And it's also a good idea to go ahead and list your expected years for the pieces of equipment, because what you will probably see if you've done things with the LCC is you've got to have replacement years. Is not all of your equipment is going to last 40 years. If you go to that table, you'll see a wide variety of years, and so you got to factor in that there's actually replacement in that total life of the system. Okay, so just kind of wanted to hopefully just seeing some of that gives people a feel for what level of detail can be provided. Like I said, that's obviously not, the mandated, but that's some real world examples of how we have done that to document. So that way people have a little bit of a picture of what this mythical creature is. So just a couple of reminders at the end here. LCCAs are performed at less than a 35% design level. These are concept designs. These are not detailed designs. You're not going to have a real detailed itemized quantity list. You're not going to have the total number of valves and things like that. Typically, like I said, project costing is parametric at 35, and so you can probably expect something similar. So utility rates. So this is another one. So this can be, depending on where you are, this can be a challenging thing to obtain. You can go to your installation, you can ask for utility rates. Some of these rates might significantly vary from a private utility provider. I'll say a lesson learned that we had is we're down here in Texas and energy is relatively cheap. The rates that we were given by some of our installations were actually so low that when we submitted for LEED actually shot back comments that your rates are too low, that we can't accept them because they varied so much from EIA.gov. So we actually ended up having to go back in and use EIA.gov rates, which at first we started to fight, and then we remembered that LEED is actually using energy cost savings, and so we actually ended up getting more credits because we were using a higher rate, which was kind of an interesting thing. But anyway, with your LCCA, that's just something to note is your rates, they can vary. There are resources out there. EIA.gov is a good spot for being able to go and find like a state average. There's a lot of variation in how you can read an energy rate, especially like electricity in regards to demand and things like that. I'll say usually we try not to get to that level of degree of detail with our LCCAs, but obviously if you were looking at something like an ICE system or something that's based off of demand, that might be, something that you would actually need to consider. I'm sorry, I know I'm running a little bit long on this. If y'all need to drop off, you're welcome to. I'm going to just kind of keep rolling here. And then there's some uncertainties with your cost estimate. Your initial investment costs, they can vary quite a bit. We've seen it where, our IGE comes in, significantly different from what the contractor's proposals are. That can be somewhat the same with your LCCA. We already talked about operations and maintenance costs and estimating that can be somewhat of an uncertainty. The actual savings that you're going to achieve, that those are impacted by weather, by operation, things like that. So those can vary. We've already talked about salvage value and service life. These are things that they have a big impact on your system. And I'll say with service life, have a project where we had a VRF system that was more or less applied in a wrong kind of installation for environment for it, and it's getting pulled out after 4 years because the O&M couldn't be kept up with. That system was selected based on a 20+ year study and energy savings. Was it the actual best solution if it wasn't maintainable in there. And obviously whoever was studying it wasn't assuming, a 4-year service life because, it was going to be abandoned. Don't want to go real far down that, but just service life and actual life of equipment is sometimes with our organizations, we'll see stuff that is, 20 to 30 to 50 years old, and sometimes we'll see stuff that's brand new that's failed. And then finally, sensitivity analysis. So with that, that's sensitivity analysis is a way to predict the outcome of a decision if the situation turns out to be different compared with a key predictor. So I kind of talked about that a little bit with, if your utility rates went up by 30% or something drastic, is the result of your study going to vary drastically? So that's something that's in the policy, and so encourage y'all to see that and document that as well. Okay, so that's so in our presentation we talked kind of what is an LCCA. We talked through the policy and there's a lot of it there. We highlighted some tools and then you got to see some real world examples. So running pretty low on time. I don't know, Gabriel, are there a bunch of questions on the chat?
There was a couple. Billy Tyndall asked, can EIA gov rates be used as a default energy cost? It would probably help the LCCAs on alternative energy.
I don't have the exact answer for that. I'll say we use ours for lead, just based on lessons learned with that. And so typically, right or wrong, our process is that we call that our utility rate when we do our projects. We go ahead and just pull the EIA.gov. It's pretty easy to document that. Like Billy said, that can somewhat help the sustainability. There's kind of two sides to that coin. Is someone can see that as skewing the economics.
And another one, Jason Manning asked, the Army policy states under energy performance and security that all projects will meet at a minimum the requirements of UFC 1202 section 2-3.1 and achieve the highest energy efficiency that is lifecycle cost effective within the program amount. UFC 1202 section 2-3.1 energy efficiency requires the design the building to achieve at least 30% energy consumption reduction from ASHRAE 90.1 baseline. Are waivers required if the LCCA cannot achieve 30% below ASHRAE baseline?
I might need to read that one. Sorry, I can't actually get the comments up. I might need to read that one to actually give an intelligent response. I think the answer, if I understood the question right, is going to be if you don't hit the 30% energy savings, your next metric is that you're supposed to provide the highest life cycle cost effective system and document why you selected that system. And so I'll probably follow that one up with a written response and just double check myself in the criteria.
Another question from Sean Crossfield. Where do we find out if a standard design has an LCCA?
Probably the best place would be is to start with your COS proponent or the district that's covering for that COS item. Is I know that they went through some process updates to go in and capture some of the LCCA stuff, but I don't want to speak for all the different COSs.
I believe that's it.
Okay, great. Well, I'll copy down the chat and I'll go through it and double check some of that. And I appreciate y'all staying with me. Like I said, tried to probably put a little too much content in there, but wanted to be able to show some real world examples with that. Hopefully it was helpful and people got a better understanding of lifecycle cost analysis and how we achieve it. Thanks.